Dits. Oumuamua's creators. Scientists finally say the quiet part loud. Harvard's top astronomer looked at the data, looked at the cameras, and said it was built. That astronomer is Avi Loeb, chair of Harvard's astronomy department, author of over 900 peer-reviewed papers, and he is not alone anymore. For years, scientists who dared suggest Oumuamua had an artificial origin were quietly dismissed. Careers were protected, reputations were guarded. The polite consensus was to keep looking for a natural explanation, any natural explanation. But the data kept getting worse. For the natural explanations, that is. Tonight, we're going through the peer-reviewed papers mainstream media buried. We're going through the trajectory data NASA couldn't explain. And we're going to arrive at the conclusion that more and more credentialed scientists are now willing to say out loud, "Stay with me," because this one genuinely changes the picture. In October 2017, astronomer Robert Werrick at the University of Hawaii spotted something unusual in data from the Pan-STARRS telescope. An object moving through our solar system at a speed and angle that made one thing immediately clear: it did not come from here. It was the first confirmed interstellar object ever detected passing through our solar system. They named it Oumuamua, a Hawaiian word meaning roughly a messenger from afar arriving first. That name turned out to be more accurate than anyone intended. Initial observations were rushed. Oumuamua was already leaving by the time astronomers turned their instruments toward it. What they managed to capture in those narrow weeks of observation produced data that has not stopped being controversial since. The object was estimated to be roughly 400 meters long. Its brightness varied dramatically as it tumbled, suggesting an extreme elongated shape, unlike anything observed in our own solar system. Some models suggested a cigar shape. Later analysis proposed something even stranger, a flat, disc-like geometry, almost like a coin or a sail. This alone was unusual, but unusual objects exist. Science moves forward. Then came the acceleration data. As Oumuamua left our solar system, it accelerated, not from gravity, not from a gravitational slingshot around the sun, which was already accounted for. It sped up beyond what any known force could explain. In standard physics, there is a term for this: non-gravitational acceleration. It means something is pushing the object that the model doesn't account for. For comets, this happens all the time. Outgassing, when a comet heats up and releases jets of gas, can produce exactly this kind of push. Simple, natural, explained. Except Oumuamua showed no outgassing, none. Astronomers looked specifically for it, for the spectral signatures of gas release, dust trails, any cometary activity whatsoever. There was nothing. A 2018 paper in Nature by a team including Marco Micheli concluded the non-gravitational acceleration was real, measurable, and this is the word they used, anomalous. Anomalous. In a Nature paper. Then Loeb and his co-author Shmuel Bayali published their response, also peer-reviewed, also in a respected journal. Their conclusion was direct. The most mathematically consistent explanation for Oumuamua's acceleration was radiation pressure, the gentle push of sunlight on a very thin, very large surface. In other words, a solar sail, not a metaphor, an actual engineered structure, thin enough and wide enough for photons to push it across interstellar space. The mainstream response was swift, dismissive, and notably short on alternative data. If this is making you rethink what you thought you knew about what's out there, hit that like button and subscribe. What's coming in the next few minutes is where this gets really hard to dismiss. Let's be precise here, because precision is what separates this from speculation. The non-gravitational acceleration was not a small rounding error. According to the Micheli paper, the excess acceleration scaled with distance from the Sun exactly as radiation pressure would predict. Not approximately, exactly. That's a specific, measurable mathematical relationship, and it fits one thing cleanly: a thin, low-mass object being pushed by sunlight. Loeb's team calculated the required dimensions. For radiation pressure alone to account for the observed acceleration, Oumuamua would need to be less than a millimeter thick, while potentially hundreds of meters across. No known natural process produces an object with those proportions. Then there is the trajectory. Oumuamua did not approach from the direction of any known star system. It arrived from what astronomers call the local standard of rest. Essentially, it was stationary relative to the average motion of nearby stars. Loeb has pointed out how extraordinary this is. It's as if it was waiting, parked, until something with sufficient gravity, our Sun, pulled it through. In 2021, a second interstellar object was confirmed, Borisov. Unlike Oumuamua, Borisov behaved exactly like a comet: outgassing, dust trail, predictable trajectory, completely natural. The contrast didn't help the natural explanation camp, because now we had two interstellar objects, and one of them behaved perfectly normally, while the other violated every model we applied to it. Scientists call this a control case, and Borisov is a devastating one. There are currently three serious positions in the scientific literature. The first is that Oumuamua was a natural object of a type we have never encountered, perhaps a fragment of a nitrogen ice planet sheared apart by some catastrophic event, or a hydrogen iceberg. These proposals have been published and peer-reviewed, but they require the prior existence of objects or events for which we have zero other evidence. They solve one mystery by inventing another. The second position, held by researchers including Loeb, is that Oumuamua was a piece of alien technology, not necessarily a crude craft, not a weapon, not anything from science fiction, a probe or debris, perhaps a discarded light sail from a civilization that no longer exists. Loeb's 2021 book, Extraterrestrial, laid this out in measured, scientific language that the popular press consistently misrepresented as fringe. The third position is the most uncomfortable: that we simply don't know. That the data is real, the anomalies are real, and intellectual honesty requires admitting our models broke down completely when applied to this object. A growing number of astronomers are settling here, not claiming aliens, not ruling them out, just acknowledging that Oumuamua broke physics as we understood it. Here is what doesn't get said enough. Oumuamua is gone. It left our solar system before we could mount any serious observational campaign. Every measurement we have came from a few weeks of rushed data collection with instruments not designed for this purpose. And even with that limited data, even with every disadvantage, the anomalies are so significant that they generated years of peer-reviewed controversy. What would we have found with more time? with better instruments, with any preparation at all. We will never know, because whatever Oumuamua was, we watched it leave, we documented that we couldn't explain it, and then we moved on. That might be the most disturbing part of all. Thank you for watching this one through. This is the kind of topic that deserves serious attention, not sensationalism. And I hope this gave you both the evidence and the space to draw your own conclusions. I want to know what you think. Given everything, the acceleration data, the solar sail mathematics, the trajectory anomaly, do you believe Oumuamua was natural, artificial, or something our current science simply isn't equipped to classify yet? Leave your answer in the comments. I read all of them, and if this video gave you something to think about, please like it and subscribe. There are more deep dives like this coming, topics the mainstream isn't touching, data that deserves a proper look. I'll see you in the next one.